This lesson is on partitioning a line segment. And partitioning a line segment isn't very different than finding the midpoint. Finding the midpoint of a line is dividing it into two congruent halves. Now, partitioning just doesn't limit the number of pieces you have. Maybe we're dividing it into 3 congruent pieces, or 5, or 8, or 12. Partitioning allows us to do that, okay? So let's talk about ratios, because in order to correctly partition a line segment, we need to first understand what a ratio is. So, a ratio is a comparison of two quantities. And the way a ratio is written is really important, okay? So in this example, it's saying, what is the ratio of apples to bananas? So I have 3 apples and I have 4 bananas. The 3 was written first because apples came first in the sentence, in the ratio. That 2 is that colon, and then bananas was written second. Okay, what is the ratio of bananas to apples? So this time bananas came first, which is going to mean the 4 is going to come first, and then apples came second. So even though we're still talking about apples and bananas, the way in which things are worded, the order in which they're worded, changes the ratio. And that's really important to remember. So let's talk about splitting up a line segment. Each of these line segments, AB, is split up into 1, 2, 3, 4, 5 pieces. But you'll notice that the location of M changes. So let's just talk about the pieces first. When I say pieces, I mean 1, 2, 3, 4, 5. That's what I mean by pieces. It's broken up into 5 congruent segments. And what you'll notice is in example number 5, M is right here, breaking it up in this position, while in example 4, M is right here. So what I'm asking you to do is write the ratio which M divides AB. And it's really important that I'm saying A to B because I need a starting point. So how many sections are in between A and M? 2. How many sections are between M and B? 3. So in this case, the ratio from A to B that M divides is in a ratio of 2 to 3. Now over here, M is different. It has 1 section on this side and 4 over here. So the ratio in which M partitions line segment AB is 1 to 4. So position really matters. So what we're going to do is let's take a look at an example of partitioning a line segment and how it will be asked of you. So it says example number 1. Given AB, A is this point 3,5 and B is this point -7,0. I want you to find the coordinates of the partition point P that divides the directed line segment AB into a ratio of, it says 3 to 1 ratio, but that is a typo. So what I'd like for you guys to do is I'd like for you to cross out 3 to 1 and I want you to put 3 to 2. I apologize for that. So we're going to divide into a 3 to 2 ratio. So I have some graph paper here because I think sometimes things are a little bit better visual at first. So let's go ahead and graph these points. A is this point 3,5. So if we go over 3 and up 5, this is point A. And B is -7,0. So 1, 2, 3, 4, 5, 6, 7. Right? B is right here. Okay. So we are going to draw that line segment. Okay? Now we're going to see about this ratio of 3 to 2. Right? Now, the reason why I wanted to draw this line segment is you can think about the slope. Think about going from B to A. How would I get to the next pretty point? I don't have to go all the way to A. The very next pretty point is right down here. It's just as simple as going up 1 over 2, right? So if I continue that pattern, up 1 over 2, up 1 over 2, up 1 over 2, you'll notice that I can divide this line segment into several congruent pieces. 5 congruent pieces, right? So now I have these 5 congruent pieces, and if I want to divide AB into a ratio of 3 to 2, notice that the 3 is where the A is. So I want to put that P so that there's 3 pieces closest to the A, 1, 2, 3, and 2 pieces closest to the B. So that's where P would belong, right? That splits it into a 3 to 2 when you're going from A to B. Okay, so that P is dividing up that line segment. Now, this is beautiful, right? It's nice and easy, it's clean, you can mark the points on the slope, but we know math isn't always as pretty as all that. We know we're going to end up with fractions, we know we're going to end up with decimals, we know things are going to be ugly at times and maybe even too large to graph. So we need a method that's going to help us to get through an example such as this algebraically. And we're going to do it just like we do midpoint. So I'm going to go ahead and use the space down here. I'm going to draw a fake line. So when you look at this ratio, remember, it means I want 3 pieces on one side and 2 pieces on the other. It's really important to note that if there's 3 pieces on one side and 2 on the other, you have a total of 5 pieces, right? So you're going to draw a line segment with 5 congruent segments attached to one another. So let's take a look at what that looks like. Right down here, I'm going to start with this point, and I'm going to go 1, 2, 3, 4, 5. So this is just a sketch of a line segment with 5 points. I'm going to put point A up here and point B down here. Okay, so we'll notice that point A was 3, 5, and point B was -7, 0. While I don't have points in each one of these dots, they are coordinates. So I'm going to go ahead and set myself up for points in each of these. So it's the same as the midpoint, just instead of there being only one blank point in between, there's several because I broke this into 5 congruent pieces. Okay? Before I find out what each of those points are, I want to decide where P belongs. Now remember, this said that it was at a ratio of 3 to 2. So I'm going to draw a little arrow such that there are 3 pieces on top and 2 on the bottom. So right here is where P is going to be. I'm going to put the P over here, right? P belongs right here. Actually, it's probably going to get in the way. I'll erase that for now. But where that arrow is P, okay? So we're going to do this the same way that we did slope, the same way that we did midpoint. Let's think about it. If I jump from 5 all the way to 0, that means I went down 5 units. And if you're unsure, you can always do in your calculator 0 minus 5, the bottom minus the top. Will give you change, right? That's the change in y. But I don't want to do it in one big jump. I want to do it in 1, 2, 3, 4, 5 jumps, right? So I'm going to divide this by 5. So that's where things were different. Last time we always divided by 2 because we were dividing to 2 congruent pieces. But here, this total number tells us what we're dividing by, and we got that by adding the numbers in our ratio. Okay, so -5 divided by 5 is -1. So this is telling us how we're going to move. So starting at this point up here, this 5, we're going to start subtracting 1. 5 minus 1 is 4. 4 minus 1 is 3. 3 minus 1 is 2. 2 minus 1 is 1. 1 minus 1 is 0. Oh, I got to this point down here and everything was great. So I know I did a good job. Now that we have our change in y divided proportionally into 5 congruent segments, I'm going to do the same for x. So our x coordinate jumps from 3 to -7, which means it goes down 10 points, right? And again, we're going to divide by 5 again. This is consistent because of that ratio up top. We're always going to be dividing by 5 in this case. -10 divided by 5 is -2. So that means we're going to keep jumping -2. So if I start at 3 and subtract 2, I get 1. 1 minus 2 is -1. -1 minus 2 is -3. -3 minus 2 is -5. -5 minus 2 is -7. Oh, I did a good job. I got to the end. I got the right number at the end, so I know that I did things correctly. And when I'm looking for P, the point that divides it into a ratio of 3 to 2, look no further than where I already put this arrow. This is my point P. So P is this point, -3, 2. That would divide it into a ratio of 3 to 2. And if I go back over here, you'll see that's what P was. It was -3, 2. Okay? Let's take a second and see if we can do another example. So for example number 2, you'll notice no graph paper. This is going to be really common because sometimes we are going to end up with really ugly numbers. While you'll always be allowed graph paper, I do recommend you really lean on the algebraic method. So it's giving us points, z, which is -2, 4, y, which is 7, -2, and wants us to find the coordinate of point P on the directed line segment, zy, that partitions zy into a ratio of 1 to 2. So again, first thing you want to do is recognize if it's 1 to 2, that means it's 3 total pieces or congruent pieces, right? 3 congruent pieces. So when I sketch my little picture, I want it to be 1, 2, 3. I can go ahead and put z at the top, z, which is -2, 4. I can put y at the bottom, which is this 7, -2. And I can acknowledge that each one of these is also going to be a point. Now, if I want it to be split into a ratio of 1 to 2, that means I need one piece on the bottom and one piece on the top and 2 on the bottom. So if I was to put it here, for example, that would be a 2 to 1 ratio. If I was to put it here, now that's a 1 to 2 ratio. 1 point on top, 2 on the bottom, or 1 line segment or congruent piece on top and 2 on the bottom. Okay, now let's take a look at our slopes and see if we can divide things up. If I jump from 4 all the way to -2, that means I'm going down 6. And again, use your calculator if you're struggling with that. The bottom minus the top will always give you the change in y. Now, what do I divide by? Now remember, this piece up here tells you where you divide, 3 total pieces. So I'm going to divide this by 3. -6 divided by 3 is -2. And that's going to tell me how I move for my y's. 4 minus 2 is 2. 2 minus 2 is 0. 0 minus 2 is -2. And look, I got -2 down here, so I did a good job. Great, now let's take a look at our change in x. If I'm going from z all the way to y, that means I am adding 9. But I don't want to do it in 1 jump. I want to do it in 3 jumps because I want 3 congruent pieces. 9 divided by 3 is 3. So let's see, if I'm starting at -2, what's -2 plus 3? That's 1. 1 plus 3 is 4. 4 plus 3 is 7, right? So we did a good job. We got to the end. Now, if I want to know where point P is, just look at that arrow we already put. P is over here. So our point P in this case is 1, 2. So this is how to find a point that partitions a line segment into a given ratio. It's basically the same thing as doing the midpoint. The only difference is you need to first figure out what you're dividing by, because it's not going to be 2 every time anymore. It divides by the total number of pieces. And you also need to decide which piece, which point, splits it into the appropriate ratio. Okay, now go ahead and do some practice problems. If you have any questions, don't hesitate to reach out.